So Ohm's law, George Simon Ohm formulated the relationship amongst voltage, current, and resistance. So it says that the current in a circuit is directly proportional to the applied voltage and inversely proportional to the result, which is I equals to V over R, V equals to IR, or R equals to V over I. Okay? Ohm's law cannot be applied to the circuits consisting of a non-linear element such as a toroid and electric arc. So for example, I have a V, I have a R, but I want to find I. So I use I equals to Vs over R, which is 24 divided by 1.2K, and I have a 20 milliampere. Same as well, R equals to V over I. 12 divided by I have a 600 ohm. Or V equals to IR, I have 11.75 volt. Another one is the Kirchhoff law. The law is formulated by the Gustav Robert Kirchhoff. He introduced two laws. One is Kirchhoff voltage law, KVL, Kirchhoff current law, KCL. Kirchhoff voltage law, KVL, states that the algebraic sum of all voltages around a closed path or loop is 0, which means when voltage increases, it will be equals to voltage decreases. What goes up, and it must be come down. For any circuit loop, we put it in the mathematics. This logo means sum. So I add up all the voltage, it must be 0. So how to implement the Kirchhoff law? Yes, like this. The sum of all voltage applied must be equal to the sum of the load voltages. How to do that? So first, I have one circuit. First, I need to know the polarity of the voltage of the current source. Second, I need to know the direction of the current for every component. Third, I need to know the voltage polarity of every component. Then I can apply the voltage Kirchhoff voltage law and create an equation. So first, I need to know where is my voltage or current source polarity. So this is my first one. This is my battery. So the long one must be positive, short one must be negative. Second, so there's no more, and then there's no more voltage or current source. Next, I need to know the direction of every component, current of every component. So I assume that all the current will flowing up from this positive and then go back. So the direction of the current is going through like this. Third, this is number 2 law. I, 2, I, 2, I. Then third is my voltage polarity of every component. So how to determine by voltage polarity? We need to see where is my current flow. So my current flow into the resistor. So this is positive terminal, and then the other side will be negative. So this is my current flowing into the resistor. So it will be positive, this will be negative. Again, this flowing through into the source. So we cannot determine the polarity because it is source. The third one is a voltage polarity for every component. Then fourth, I need to apply the KVL. Whether I want to go in this way as positive or I want to go back in this way as positive. So now my KVL is go in this way as positive. So I need to create an equation. According to the Kirchhoff voltage law, summation of all the voltage in the loop must be equals to 0. So which means I need to know where is my starting point. So my starting point from here goes one round like this. So when my direction going into meet this negative first, I will put negative V, E, or negative E, then I plus V1. So I go again, or I touch plus V1. So I put plus V1. And then go again, I touch plus first. So V2. I put V2. Then I go back. There's no more component. So it will end at here, which is equals to 0. So I move the E, and then I rewrite the equation. E will become V1 plus V2. So this is how we say create an equation of the voltage, Kirchhoff voltage law, where all the summation of the voltage in the loop will become 0. And For example, the voltage drop around any closed loop is equal to the applied voltages. So first I need to know the polarity of the voltage or current source. So this is my current source. So I know that this is positive, this is negative. Done. Second, I need to know where is my direction of the current for every component. So where is my direction of the component? So I assume that my current will be flowing out from here. So it will go like this, go like this, go like this. Third, I need to know the voltage polarity of every component. So I have these few types of resistor. So the current is flowing through in first, so plus here, then in plus, 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 then plus. Then I apply a Kirchhoff voltage law. For example, I apply this direction. So I start from here. It go here, it will touch negative, so negative 10. Then go here, positive 2. Go again, positive 2. Go again, positive 2. Go again, positive 2. Go again, positive 2. Then I have equate, it become 0. Same for this example. I need to know where is the polarity of the voltage or current source. So this is here. Positive, negative. Then I assume that the direction of the current is from this positive side out. So go out, it will come to here. This will become my positive. Come to here, become my positive. Come to here, it cannot become positive actually because this is the number one polarity voltage or current source, which means it is actually positive here. And then the current will flow in again, it becomes positive. Flow in again, positive, because I assume the current is flowing like this. Then the voltage polarity of every component done. Then I need to apply the KVL. Now I don't want to apply in this way. I want to apply in this way. So I try let you know if I apply this one how I can create an equation. First, if I start from here, I go from here, negative minus 1. Then go again, negative, so minus 1. Go again, I meet negative first, minus 2. Then go again, negative 1. Go again, negative 1. Then come here, it become positive 6. Then ending become equals to 0. So we can check back. Plus 6, minus 1, minus 1, minus 1, minus 1, and minus 2, it become 0. So this is how we apply the Kirchhoff voltage law. What if we have a few circuitries? Circuitries means this is one circuit. This is one circuit, something like we cannot see. I just take one of the loop. This is another circuit. This is another circuit which is connecting through other way. For example, fan. For example, it is connected to one source here. This is connected to one source here. This is connected to one source here. For example, only. So how can we go to define? So first of all, we need to know where is the loop we want to define. Center, this one. This is the loop we want to find. But don't panic. First, we need to determine where is the polarity of the voltage or current source. So we have two sources. One E1, one E2. Long is positive, short is negative. Long is positive, short is negative. Where is my direction of the current for every component? So I assume my I1 is going up. My I2 is going this way. My I3 is going up. My I4 is going this way. I assume only. I simply assume. Then, third, I need to know where is my voltage polarity for every component. So, since my current is going up, so go up, this is my positive. Go here, this is my positive. See, this current is going up, positive. This one is not coming into here. This is called branch. This branch, the current is going up, so this is positive. Then, in this branch, the current is going this way, so this is positive. Because current will go to here, positive. Okay? So I know the three things. Voltage polarity of every component. Now I want to apply KVL. So next, for example, if let's say I assume that I want to apply in the clockwise direction of the KVL, then I can create an equation. So I start from here. I found negative first. So minus 1. Negative E1. Then I go again. I found positive first. Positive I1 times I1. I want to find the voltage across here. So V equals to IR. So I times R1 is my V, and it is positive. Then I go around. This is positive first. So I plus. So what is the voltage here? I2 times R2. So I2 R2. Then I go and found it. Oh, I come here negative first. So negative. Then I3 times R3. I3 R3. Then I go here again. Go back again. This is negative first. So sorry. I come here. I found that this is positive E2. So I plus E2. Then I go back to become minus first, minus I4 R4. Okay. So this is how we apply the KVL. Please follow this step, or else you will confuse. What about Kirchhoff current law? Kirchhoff current law states that the algebraic sum of the currents entering a node or a closed boundary is 0, which means the current entering a node will become the current existing. What goes in must come out. For any circuitry, summation of I, summation sum of the I will become 0, or total in become total out. For example, here I1 in, I4 in, I3 out, I2 out, which means I1 plus I4 must equal to I2 plus I3. This one. Or I move to here, I1 plus I4 minus I2 minus I3 become 0. For example, this is the node. So 1, 2, 3 is in, 1 out, 1 in, 3 out. So let's have a look on this network first. So plus, I assume that in is plus, plus 5, plus 10, plus 15. Plus 5, plus 10, plus 15 is equal to plus 30 out. Okay? Plus 30 equals to plus 10, plus 10, plus 10. Short circuit. Circuit element with the resistance approaching 0. So this is 0 ohm, where there is no voltage across that. No voltage difference exists. All points on the wire are the same potential. No matter this one is 5 volt, this will be 5 volt, this will be 5 volt. No difference. It's not like waterfall. It's no different. Current can flow as determined by the circuit. Current can flow through. This is called short circuit. Open circuit means open. The circuit is open that no current flowing through. How to make it open? We inject a lot of resistance, where the resistance can go to infinity. Usually it is about mega ohm. So there's no current flow So no current will flow through, but there's a voltage, which means if let's say I use a multimeter to tap that 2 points, we can measure some voltage. We also need to know the branches, nodes, and the loops. So what is the branches? Branches is the electric component in one between the nodes. So this one is one branch, and another branch. Nodes are A, B, C, D. This is called node. Loop. One circuit is called loop. And then circuit model, we have a series, we have parallel, and series. Series means one of the terminal. This is a component, right? One of the terminal connected to the another terminal. Then the other side of another terminal will connected to the other component, like this. For parallel, the components 1 and 2 are sharing the same nodes. For example, terminal for the component 1, terminal for the component 2 are sharing A and B, same nodes. For example, this one, parallel and series. We have a parallel connected with a series. So 1 and 2 are connected the same terminal. But this another terminal is connected the other side. So we have a parallel and series. This complete circuit uses the following: an energy or power source. This is energy power source. A control device. A load is this one. Conductors, this one. Conductors is a wire like this. Insulation not shown. Then we'll talk about the series resistor and the voltage division. Series resistor will lead us to the voltage division. How to do that? For example, I have one circuit like this. Okay, I want to study the equivalent resistance. Equivalent resistance means some resistance we can sum up like this, and how to be related to the voltage division. So in this circuit, I have a V, I have a node AB, I have a resistor 1, resistor 2, my current is here, then my plus minus V1, plus minus V2. Okay, so I know that my V1, I apply the Ohm's law, V equals to IR. So V1 equals to I1 times I times R1, V2 equals to I times R2. Then I apply Kirchhoff voltage law. So I start from here, negative V1 plus V2, plus V1 plus V2, coming back becomes 0. So which is in this equation. Then I rewrite the equation, V equals to V1 plus V2, and then which is I. So I substitute this one into here, I substitute this one into here, which is here and here. I found that I times R1 plus R2 is my V. Then I move around. Become I equals to V divided by R1 plus R2. And I know that I can rewrite becomes V equals to I equivalent. V equals to IR equivalent. V equals to IR equivalent. So I know that we can see that my R equivalent actually R1 plus R2. So I can find the equation R equivalent equals to R1 plus R2. So when the resistor are connected in series, we can rewrite as a R equivalent, where we sum the R1 plus R2. On the other side, if I apply V1 equals to IR1, this one, then I substitute the I into here, or V2 equals to IR2, I substitute my I into here. So I see that, when I substitute this one into here, I found that V1 equals to R1 divided by R1 plus R2 equals to V times V. Or V2 equals to R2 divided by R1 plus R2 times V. This is second equation. We call voltage division. Put it in a simple way. In this circuit, if let's say I want to find V1, what I need to do is, my V1 actually I use R1 divided by total resistance times total voltage across this node AB. Same as well, if I want to find V2, the equation is I use R2 divided by all resistance times total voltage across the terminal AB, which is in here. So remember, series resistance R equivalent is a plus like this. Voltage division is like this. And this is how we derive. So parallel resistors and the current division. Just now is a series resistor. Now we talk about parallel resistor. Parallel resistor will relate us to current divisions. So assume that we have a voltage source V, and then we have a resistor R1, resistor R2. Then we assume that the total current I is like this. We have a node 1, node A, node B. Then in this branch, we have I1. In this branch, we have I2. We can actually simplify the circuit into like this. We call as a R equivalent. So how can we relate it into how to find the equivalent resistance for the parallel resistors, and also how can we interrelated with the current? So first, we know that V equals to I1 R1. Now V equals to I1 times R1, where it is the same because same node, right? I1 R1 equals V1 equals to V2, which is I1 times R1 equals to I2 times R2. So we can write V equals to I1 R1 equals to I2 R2. Then I can rewrite like I1 equals to V divided by R1, or I2 equals to V divided by R2. Then I apply Kirchhoff current law at node 1, which means all in equals to all out. So my I equals to I1 plus I2. I equals to I1 plus I2. So I substitute my I1 into here, I substitute my I2 into here, I find this one. Then I factorize the V, I found this one. Which means I can equivalent to V equals to R equivalent, resistance. Where I can rewrite become 1 over R equivalent is equals to 1 over R1 plus 1 over R2. Or my R equivalent is R1 times R2 divided by R1 plus R2. So have a look. The equivalent resistance is this equation, or usually we use this equation. What about the current division? Here is the current division. Come back to the equivalent circuit and also the resistance. So I start from here. V equals to IR equivalent. So my IR equivalent actually is R1 times R2 divided by R1 plus R2. Okay? And then I know that my V equals to I1 times R1. I1 times R1. My V also equals to I2 times R2. So let's have a look on the first equation. I1 equals to V over R1. So I can substitute my my V here. I can substitute my V here into this one, and I found this one. Or I substitute my V, which is this one, into this one, then I found this one. So have a look. If let's say I want to find my I1 here, I use R2 times my total current divided by R1 plus R2. Or if let's say I want to find my I2 here, I use R1 divided by R1 plus R2 times my total current. This is the simpler way. Let's have a look on the example. So if I have one circuit like this, so it looks like very complex, but we try to sort it out one by one. First, I found that this is a series resistance, so I combine it. 1 plus 5 becomes 6 ohm, become like this. Then I know that this is a parallel resistor because the resistor are connected between same node. So parallel we usually write in this 6 ohm parallel with 3 ohm. What we do is 6 times 3 divided by 6 plus 3, and then we found 2 ohm, this one. So we have another circuit like this, simplified circuit, 6 ohm, 2 ohm. Then we found that this branch is a series resistor. So 2 plus 2 it becomes 4. Then 4 ohm and 6 ohm are parallel. So 4 ohm parallel with the 6 ohm, we use 4 times 6 divided by 4 plus 6, we have 2.4 ohm. And then we put into simpler network. So 4, 4, 8, 8. Then this is the equivalent resistance of 2.4. So my total equivalent resistance is 4 plus 2.4 plus 8. 4 plus 2.4 plus 8 become 14.4 ohm. So can we see that how we apply the series resistor and also parallel resistor? So this is how we do that lah. What if we want to interrelate with the voltage division or current division? So let's have a look at one example. 12 volts supplied to 4 ohm and a terminal of nodes of A and B. The resistors are the 6 ohm and a 3 ohm connected in a parallel. For example, the equation, the sample asking us to find the V0. V0 means the voltage across the terminal of the resistor, and also the I0. So what we do is we need to simplify the circuit first, so that we can use the information here to reverse back to find the value. So what we need to do is we need to find the equivalent resistance for here. So 6 ohm is parallel with the 3 ohm. So we write like this: 6 times 3 divided by 6 plus 3 become 2 ohm. So we have this one, 2 ohm. Plus minus V0, actually this voltage are the same as this voltage. So I can bring it into V0 like this. So this one is copy, copy, copy. Then node AB, AB. Then I have my 2 ohm and plus minus V0. So I apply the voltage division. Now I want to find V0, right? So I apply the voltage division. Voltage division saying that if I say I want to find the voltage here, what I need to do is I use 2 divided by 4 plus 2 times 12. 2 divided by total resistance times total voltage. So I have 4 volt. Then I want to apply the current division. I need to know the total current first. So what I need, how can find the total current is actually I use V equals to IR. My V is 12 volt. My R is 4 plus 2 amp. So I have my total current. Now I want to find my I0. I0 is this one, this branch. So come back to this circuit. If I applying current division, my I here, I will use I0 is actually, I use 6 divided by total resistance. Is it? Total resistance times total current. 6 divided by total resistance, 6 plus 3 times total current, 2 amp. Then I found my 4/3 ampere. So this is how we apply the series resistor, parallel resistor, voltage division, current division. And when series resistor, the equivalent resistance, how to find it. Parallel resistor, the equivalent resistance, how to find it. So as a recap, we learned about the system of the unit. You learn about the charge, actually charge and the current. You learn about the voltage, power and energy, circuit elements, Ohm's law, the nodes, branches and loops, Kirchhoff law, Kirchhoff voltage law, Kirchhoff current law, series resistor and voltage division, parallel resistor and current division. So this is the end of the chapter 1. Thank you very much.